Hello. In this tutorial, we'll see how we can integrate the data from the user's phone accelerometer into our game, so that if the user tilts his phone either left or right, then the player will translate horizontally left and right accordingly in the game. So let's do that. Open up the player control script in Visual Studio, because that's where we have programmed the logic for the player movement. And let's create a public bool that we will call mobile enabled. We're gonna use this bool to select between controlling our player's horizontal movement either via the left and right arrow keys on the keyboard or the user's phone accelerometer. And there is no need to initialize this bool from inside the script. We'll initialize it instead from the editor since we've declared it as public. Also, let's create a new private float here below the translation factor float and call it translation factor mobile. We'll use this float to smooth out the player's horizontal movement in the game when controlled via the phone's accelerometer. Let's initialize it to 5. Now let's go to this section of our code that implements the player's translational movement in the game from inside the player logic function. Let's take a moment to recap how we dictated the logic for the player's horizontal movement in Unity with C# code, because it overlaps in big ways with how we can control the player's horizontal movement from the user's phone accelerometer here in this script. We first wrote a switch statement that checks for the player's current running direction in the game. And then we fixed his horizontal movement against a virtual horizontal axis for each running direction case. In the case when the player is running north, we fixed his movement on the x horizontal direction given by the x component of the vector3 player vector variable to the virtual horizontal axis multiplied by a speed factor per second. And the case is similar when the player is running east, only this time we're fixing the player's movement on the z direction to the virtual horizontal axis with a negative sign to correct the axis direction on the left and right arrow keys. Likewise, when the player is running west, we're restricting his movement in the z direction to the default virtual horizontal axis. Now, what we want to do is fix the player's horizontal movement in the game in every direction that he's running in against the tilt axis of the user's phone accelerometer, which is always going to be the x-axis. And conveniently, we only need to change this part of the expression in each running direction case to input.acceleration.x. But let's actually undo what we just did and cut this line, and then write an if statement that checks the value of the mobile enabled bool. And let's also make this if statement check for the other case when the mobile enabled bool is false in an else line. Then we'll paste the line of code that we've cut earlier here if the mobile enabled bool is false and the player is running north. We've created the selection structure because we would like to keep the option of controlling the player's horizontal movement using the left and right arrow keys from the keyboard for testing and debugging purposes. All we have to do to switch to this case is set the value of the mobile enabled bool to false from the editor. Now let's copy this line and paste it here when mobile mode is enabled, and then replace this part of the expression with the one we saw earlier, which was input.acceleration.x, and change the smoothing factor to translation factor mobile. And we're using a different smoothing or translation factor for when the player's horizontal movement is controlled via the user's phone accelerometer, because we want to decouple it from the other case when the user controls the movement of the player with his keyboard. This way we can control each case separately. Okay, now let's copy this if statement selection structure and do a similar thing for the other two direction cases while considering the respective horizontal axes. And let's not forget to respect the negative sign for the axis when the player is running east. Notice that in this case, although we're adjusting the movement of the player on the z-axis, which is the horizontal axis in the case when the player is running east, we're still controlling it using the x-axis of the phone accelerometer. This is because the user's phone is moving in the real world with respect to real coordinates, while the player is running and turning inside a virtual world with virtual coordinates imposed by Unity. So in the real world, the tilt axis is always considered the x-axis of the user's phone accelerometer, irrespective of how the player is moving in our game. This is a crucial point that you must know if you want to develop games for mobile phones in Unity. Okay, now our game is fully ready to receive input from the user's phone accelerometer. So let's save the changes to our script and go back to the editor. Let's not forget to initialize the mobile enabled bool to true by ticking it from the inspector window of the player's game object. Save the changes and plug your device to your computer via USB. Here I have the Unity remote app running on my iPad to test the accelerometer feature we've just programmed. Hit play. Now if I tilt my iPad either to the left or to the right, then the player translates left and right accordingly in the game. And if I turn east and then tilt my device, then the player tilts with it as expected. Let's see if the player can move with my iPad's tilt in the west direction. Hit respawn. And now the player is translating in the game with my iPad's tilt. Wonderful, everything is working as expected. You can see that Unity has made this seemingly complex process childishly simple. And this is one of the main reasons that makes Unity so popular among beginner developers. It's just simple to use. Now if you're happy with what we have done so far in this tutorial, then cool. There is nothing more left to do in this tutorial. You can just move on to the next tutorial. And what I'm gonna do now is try and adjust the tilt sensitivity from the player control script so that the player's horizontal movement does not jitter with the slightest tilt from the user's device. So if you're up for that, then stick around. Now what I'm gonna do is step inside the update function from the player control script in Visual Studio and output the value of the user's phone or tablet's tilt around the x-axis to the Unity console using the debug.log method. And we're doing this because we want to observe the degree of the device's tilt using numbers so that we know how to adjust the sensitivity of its tilt. Let's save the changes to our script and go back to the editor. And let's look at our console window here, hit play. And here is a second screen showing you my iPad. You can see in the console window that the values of my iPad's tilt are centered around 0 since I'm not really tilting it. Don't mind that the player has died in the game. Our code will still work and we'll still be able to see the tilt values from the console window because we put the debug.log inside the update function of the player control script and not inside the player logic function. Now, if I tilt my iPad ever so slightly to the right until it reaches this tilt degree, which corresponds to a tilt of positive 0.1 according to the Unity console, then I want my player to start translating to the right in the game. So the user has to really tilt his device in order for the player to move in the game accordingly. And for the left tilt, we'll simply mirror the tilt value to minus 0.1. And you could choose a lesser or a higher tilt degree or value for your game, up to you really. And yeah, I forgot to mention that Unity treats axes from the phone's accelerometer in the same way it treats virtual axes, in that it keeps the range of their values from -1 to +1, with -1 being all the way left of the axis, 0 being the center of the axis, and +1 being the farmost right of the axis. So now let's go to the player control script and include this optimization for the player's horizontal movement in our code. We'll start with the north case as usual. Let's cut this line inside this if statement, and then nest a new if statement that checks if the user has tilted his phone either slightly right or slightly left, which we determine to be all the tilt values that are less than positive 0.1 and greater than minus 0.1. If our tilt value is in that range, then don't move the player on the horizontal x-axis at all. Now let's write an else if statement that checks if the user has really tilted his phone to the right, which we determine to be values past positive 0.1. If that's the case, then we want to linearly interpolate, and you know what linear interpolation is from the Can Behavior script tutorial. It essentially allows us to transition between two values smoothly, i.e. interpolate the two. So, if it's the case that the user's phone accelerometer is reading a tilt on the x-axis that's greater than positive 0.1, then we want to interpolate, i.e. transition from the current degree of right tilt to positive 1, which is the maximum degree of right tilt, as fast or as smooth as translation factor mobile times time dot delta time. Now let's copy the code for this else if statement and paste it right here to extend this if statement so that it checks for the case when the user has tilted his phone left past the minus 0.1 tilt value or degree. If that happens, then we want to linearly interpolate between the current tilt degree and -1 in the same transition steps as before. And we put -1 here because left tilts are defined as being negative in Unity. These adjustments or optimizations should make the behavior of the horizontal movement of our player using the user's phone accelerometer much superior. Now let's copy this entire block of code and go to the other two running direction cases and paste it in each of them. Let's adjust what needs adjusting in each of these two cases. In the east direction case, the horizontal axis of the player is the z-axis. So let the user's phone accelerometer manipulate the z component of the player vector variable. And in the case when the player is running east and the user has tilted his phone to the right past the positive 0.1 tilt value, we want to interpolate between the flipped current tilt x-axis, so put a negative sign here, and -1. Similarly, if the player is running east and the user tilts his phone to the left past the -0.1 value, then we want to transition from the current mirrored or flipped tilt x-axis to positive 0.1, also in steps of translational factor mobile times time dot delta time. Finally, if the player is running west, then his horizontal axis is the z-axis. So let's make sure that the user's phone accelerometer is adjusting the z component of the player vector variable when the player is running west, and keep everything else unchanged in this big if statement. Save the changes to a script and go back to the editor. Here is a second screen showing you my iPad being connected to the PC running the Unity editor and running the Unity Remote app. Hit play. Respawn. Now if I turn my iPad either slightly to the right or to the left, then the player remains fixed in his position. Let's respawn. And if I tilt it really right, then the player will translate with me in the game. Respawn. And finally, if I tilt my iPad really left, then the player will move with the iPad's tilt. You can clearly see that there is no jitter in the player's horizontal movement with respect to the phone's accelerometer, which is a drastic improvement if you ask me. And don't mind that the movement of the player seems abrupt. This is because we're mirroring it from the editor to our phone via USB, which causes the game to lag. When our game runs natively on mobile phones, it's gonna be very smooth. And with that comes the end of this tutorial and the end of this series. There is just one extra tutorial that will show us how to export our game from the editor so that it can work natively on mobile phones. It was a real pleasure making these tutorials for you guys and hearing your feedback. I really enjoyed it, and I hope that you find these tutorials beneficial. But more importantly, I hope that these tutorials showed you that game development does not need to be complicated or tedious. I really hope that with the knowledge you've gained doing these tutorials, that you'll go on and have amazing game development careers. I can't wait to see what kind of games you guys are gonna make. Thank you. Really thank you. Bye.